Okay. Hello class and welcome to the HMGT400 class, and this is the first live session. In this live session I'm going to review the exercise 1, individual assignment 1, and answering your questions. First thing first, I ask you start with Jenny. Introduce yourself very short and give me more information about the software you have used for the analysis. And then we can keep going with the other member of the class.
Hi everyone, my name is Jeannie. I am almost completed all of my classes, and the only software that I have used is Excel.
Okay, great, thank you, Jenny. Jonan, can you hear me? No response. Tiffany, you are muted. If you unmute yourself, please introduce yourself. And Tiffany, Kate, okay.
Can you hear me?
Yes, sure.
Okay. Hi, I'm Tiffany. I'm near completion as well. I have only used Excel as far as systems go.
Okay, great. And Elisa?
Hi, can you hear me?
I can hear you, but if you keep closer, come closer to your computer, so probably we can hear you better.
Well, I'm Alicia. I'm almost finished with my degree as well, and I've only ever used Excel as far as
okay. And we have two Tiffany, right?
Yes.
Tiffany, Kate?
Yes.
Okay, Tiffany, do you want to introduce yourself?
So I am also near completion, and I have only used Excel.
Okay, and you, okay, all of you are saying I am only use Excel. You prefer to use Excel for the class, all of you?
Yes.
Okay, Joy?
Yes, hi.
Hi, Joy.
I'm almost finished as well, and I've only used Excel,
Okay.
and I prefer to use Excel.
Okay, and Leonardo? Okay, can you hear me? You are muted. Okay. Okay, class. By default, I'm going to walk through the RStudio, but because most of you, at least all of you, I never heard from Leonardo, but all of you using Excel, I will start with Excel first. And then after that, I will walk through the RStudio, and then more likely you're gonna like that because that's the package that make everything much easy to use, specifically not for the exercise, specifically for the final exam. But anyhow, it's up to you to use Excel or RStudio. For the first individual assignment for the exercise 1, any of you submitted? I saw a few members of class submitted exercise 1. I never reviewed them yet. All of you submitted or are waiting for this live session to submit that?
I'm waiting.
You submitted? Okay.
I've submitted mine, but I want to get through this live session and take a look at what I submitted and probably most likely resubmit again.
Okay. Let me share my screen and go through this. Where is the Excel? Okay. Can you see my screen? Someone confirm that. Can you see my screen?
Yes.
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 Okay. These are actually all of these exercise. We have 5 exercises, exercise 1 and 2. You just need to look at the mean. For this class, we are working through 5 different functions. When I say function, I'm talking about in viewpoint of the Excel or RStudio. The first function is a count function for the number of observation and the mean, the standard deviation, second and third option. And we're gonna go through the p-value based on the t-test. And for week 1 and 2, for week 3, because we have 3 population, we're gonna walk through. We need to use ANOVA test, because whenever you have more than 2 population, the t-test is not the best fit test. And for week 4 and 5, we are going to use regression for week 4 and the logit model for week 5. But if you are using Excel, then for week 4 and 5, we're going to use the regression model. The way I'm teaching this class is we have 4 live sessions. So the first one is for individual assignment 1 and exercise 1. The second, every 2 weeks, we will have a live session. For today, I will review the exercise 1, individual assignment 1, and for week second, I'm going to review the individual assignment 2 and the ANOVA test. For the third one, I will review the regression, and the last live session, I will review the final exam. If you need any specific live session in person, so I will be available and by schedule. But most of these material, I already created them and put them on the YouTube. You can look at them. Okay, for the first exercise, we have 10 variables. And for these 10 variables, we would like to see how is the hospital characteristics change between 2011 and 2012. And we're going to answer this question, in which year hospitals has better performance. And a specific hospital, because we are looking at through the means, but in every specific hospital has a better performance. Let me go to the class and show you. I like to make sure you have everything. You see everything actually in the class. The class has a class instructions. In the instruction, for example, there is Excel exercise here. This is this file. I'm looking at this. Wait, this file. All of the exercises here. For each week, you can complete one and populate any of this. Actually, the related part of that exercise and keep the other part not completed. So you don't need to copy from the class. You can download this file and use it continuously. So then you can keep that for yourself. For every week, for all of the exercise, there's only one data set. HMGT400 Using. This is a data set. And if you open this data set, this data includes about 3,030 observations and all the variables. The format of the file is a CSV file. So if you are trying to use Excel, make sure to save file as Excel file. Change here. Any type of Excel, even if you are working with the old version of Excel, there's possibility to convert to the 97 to 2003 worksheet. By default, I go with this Excel workbook. I have the 2016 version, but doesn't matter. You can use 97 version even has the same function. If you don't do that, so whenever you close the file, all the function you have created will be disappear. This is really important for the students who are using Excel. This is the file. This is the RStudio codes. And if you're using RStudio, there's 2 types of codes here. The first code is using the deploy package. The second code is the no deploy package. And there's a video to show how to use this Excel or RStudio, mostly RStudio, but there is a file for Excel as well. I posted for a few students, they asked me a question. For the week 2, exercise 2, actually, the data set is still the same data. You don't need to use the same, download the data. You can use still the same data set here, but you should download the codes. And for week 3, 4, 5, these are for the exercise. And then we have 2 individual assignments, individual assignment 1 and individual assignment 2, 1 team project and 1 final exam. All the files for the individual assignment are here. I can say 99% of students already submitted the topics. I approved the topic. A few of you had a problem with topic, so I just ask you to just modify the topic, and I look at them the night before of the 2 days ago, and I gave the feedback to all of you. Anyone submitted last night, I never looked at it yet. And for the individual assignment 1, when you submit your file, I will review that, give you the feedback, and if you receive more or less than 80% of the grade, I'm talking about 100% from 1 to 100, anyone who received the grade less than 80%, there's a chance to review the individual assignment 1 and submit by individual assignment 2, both of them together. For individual assignment 1, if you are working with RStudio, the codes are available. You can post and send me an email. I will submit the codes to you. If you are working with Excel, I will review one example, and then you are responsible to do that by yourself. And there's example of the draft of the individual assignment 1. You can look at that draft. I will walk through this later in this session. Okay, let's go. Any questions so far here? Okay, let's go to the Excel. For the first, I think the first exercise ask about 2011, 2012. Yes, yeah, let me open different file because this is for teaching and non-teaching. This is it. Okay. You know, the Excel file is show you everything here, right? You see all of this data here. I already download the data. I save it as Excel file, and then I'm going through the functions. And there's some, by default, there are some functions in Excel. You can use those functions. The way I'm using the function, I'm writing the codes for each function. So basically, I'm Excel, except the regression, I am not using the default function by Excel. But if you prefer to do that, this is completely fine. It's up to you to reach what you want to do with Excel, but you should get the same result. You can use any other packages, but I expected to see the correct response. A few students using SPSS, 1 or 2 using SAS, some of you using RStudio, and some of you are using Excel. Excel and RStudio are 2 most popular common software. So whenever you are using with Excel, as I said, the first step, save the file as Excel file, not CSV file. The class file is a CSV file because for RStudio user, they need to have that one. And the second one, so I'm going to hide most of the row. I don't need them. And see, I'm just highlighted this one and hide them here. So now I have the name of variable and I have the data. I don't need to see the entire data. And this is, I'm going to walk through one example here, and then you can do for the other part, because as long as you know the function, it's easy to go. The first function, and you know, the data set is a long data. Anyone knows the differences between long data and wide data? Any response? Okay. Let me show you an example. If we have only 3 variables here, let's say ABC, and the A is to the year, and the B is a gender. Let's go with any variables. Let's say hospital cost. I'm going to give you a few examples here. And let's say 150 and we'll try. Don't even this one. When you have a long data, first you have the first year and then you have the second year. So basically, you have only one variable for both years. If it is year and this is the cost, the long data you have the first year and you have the second year. But if you had a wide data, you should have this. Year 2011, year 2012, cost 2011, cost 2012. Most of the time, the Excel functions work with wide data because usually you can go with a sum function here and compute the sum. You can go with the count function here and compute the count. You can go with the average function and compute the average. But if you like to use the long data, you should use countifs, average if, standard error if, standard deviation if. So you're gonna use that because you should filter whenever you're using the countifs. Excel will filter this too. For example, if you use countifs 2011, Excel will use only these two variables. Otherwise, if you use the count, when you are using the count with the long data, you will have all of them together. So it's not the case for this exercise. So we have a long data because you look at this, we have 2012, 2011. So this is a long data. So for that reason, we should use the countif function. Look at this function. This is the countifs. Everything is the same. And then, for example, I have this. The first one is the hospital beds. This is the other function. So let me go open all of this on the item. First thing first, try to find the column ID. Column name, some column, find the column. For example, for the hospital where the column is F, in my computer, I'm not sure if you are using the same data, you should have the same. But make sure the column F is for hospital bed. Identify the column here. So I identify all the column here. So this is okay for me. For example, for the hospital net benefit, you don't have a column, you should divide and you should create that column D minus E, total hospital cost minus total hospital revenue. This is the S, T is the X and Y. So for this, I'm going to hide this because I don't like to confuse you with a lot of number here. So I have a hospital bed and I'm going to use to countif. Countif, column F, right? But I should filter the data for 2011. So the 2011, this is the column C. I should filter the data. I say count if the data is for 2011 only, and then give me the count if the case are more than 0. Don't count anything that's missing. So this is the function. I'm going to this, filter by 2011, and then if F column hospital beds, if more than 0, there's a missing, don't count them, and then enter. So you can see this one, 1505. For the means function, you should use the average. Average is for the y data, so averageifs, still F column F. I filter them by 2011. The differences between countif and an average_if is the location of the filter. The countif, the location of the filter is the first filter the file and then count them. The average is different. Average is first compute the average and then filter. This is the Excel default. You cannot change it. So this is the difference between two files. But everything is the same. But you should see the number of words you want to see there. So the number of, I'm going to say, okay, look at all of this column F, starting from column F2. This is F2, right? And end to F3031, and filter by 2011, and give me the means. And then the same for the standard deviation. For the standard deviation, you have a standard stdev.s or stdev.p. Whenever you have a small numbers, the p and the s stands for sample, and the p stands for the population. So whenever you have a very big data, usually it's better to use a p. Whenever you have a 2, something like this here, because you have a population 3031 hospital, and then you have 2 samples, sample for 2011, sample for 2012. So you're going to use the standard deviation.s, and then filter the data by 2011, and then look at F2 till F2031, and then give me the standard deviation, and you should shift enter. This is it. The same for 2012. You have this 2012 here. It's still the same. So then here is 2011, here is 2012, the same function. Everything is the same, only the year changed. Everything is the same, year changed. And then whenever you have all of this, you need to compute. I will back to other variable, but whenever you have all of this, you should compute the p-value, because you have here 376 for 2011, you have a 376 for 2012, but the question is there any significant difference between them? It is very easy to understand based on this example. They are the same, and they look at the variance, the standard deviation. I can easily say it's not significant, but the point is what you want to do with the other variables. So for that reason, we need to compute the p-value. To compute the p-value, you should use this formula. This is the formula. Mean for the first population minus the mean for second population, the absolute value of the mean. So if there is if this number is slightly smaller, right? 376.6, 376.8. So this is a small. So if you compute the mean, it's going to have this one, right? You have this one, minus 0.191. So this is the absolute value for this. And then you should look at this number error divided by n. So the file, the Excel computed the standard deviation. So if you want to compute a t-test, you need to convert the standard deviation to a standard error. Anyone know how to compute that? Anyone knows how to compute a standard error from the standard deviation? Okay, this is the formula. So for this, so whenever you have this mean and standard deviation, create another file, another row here. I just the same hospital, so I just use that. So I say, okay, copy this one from here. This is equal this one, equal this one, and this. Look at this one. A standard deviation divided by a square root of the number of observation, the square root of this. B3047. This is this. Look at this file. this one divided by a square root of 1505. And the square root is this one, right? This is the square root. You should do the same for this. And we are going to write, so everything is this. So this is this one, this is this one, this is this one divided by a square root of 5025. So whenever you have these two, you should compute the t-value. For the t-value, actually we are writing this formula here. So I wrote this formula here. This mean minus this one mean. Because I'm using the two-tail t-test, for me it doesn't matter to be positive or negative. So it is okay if you don't put the absolute value here. But if you're gonna give if you like to get the positive, you should put absolute here. So whenever you have this variable here, this minus this, if you this number, right, and if you write absolute value of this, you have this one. This is the same actually. This is negative, this is positive. This is the same. I'll give you more numbers, see down exactly the same. Okay, for the t value, you need to write this formula here. Mean for the first population minus mean for second population divided by a square root of a standard error on power of 2 divided by number here plus a standard error on power of 2. You know, for the power, you should use this. So for example, 2, if you have a 2, you want to compute the 2 on power of 2, you should do this shift 6 on power of 2, right? Give you 4. For the power, you should use this sign for the power. If you press shift with 6, you can get this power sign. So you have a t value here. And when you have a t value, you need to compute the p value. The p value is this one, ttest, for the absolute value of this. Look at this. Absolute value of t, and we are using the two-tail t-test, so you need to define the degree of freedom. The degree of freedom for the t-test is n-1. So look at the highest number, and the highest number is a 5025. So I use the ttest of t value for absolute value of t, and then for the two-tail t-test. Anyone knows what's the difference between one tail and two-tail? Okay, let me go through internet and give you some example for this. T-test here. If you look at this distribution, if it's open here, okay. If you can like to open this, here you go. Let's just look at this figure. And this is it. Okay, here, if you look at this, you know, this is, anyone knows how we define the alpha equal 5%? Do you know this one or no? Anyone knows about this? Okay, let me copy this someplace. I don't like to stay in this website page. Okay, you stay here. Close this page. So this is the two-tail, right? Whenever we say alpha equal to 5%, when we say alpha equal to 5, consider this as alpha. alpha equal to 5%, does mean with confidence interval of 1 minus alpha equal to 1 minus alpha. With 95%, we can make sure that this analysis is correct. It means alpha. So the alpha is the error term. When you say alpha equal to 5%, it does mean we have 5% error. So whenever we are looking at a two-tailed t-test, I don't care the value should be over here or over here. Look at the t value. T value, by default, they computed the alpha for 5% and for 120 observation as a 1.96. This is the t value for 0.5%. Alpha equal to 5. And we should divide, because there's a two terms, we have to say divided by 2. It's going to be 5% divided by 2. 25%. So if you have the very normal distribution, whenever you have an alpha equal to 5%, you should get, for the t value, you're going to get 1.96. Any number between less than 1.96 is not significant. Any number between 1.96 and minus 1.96 is not significant. Any number more than that, it's significant. This is the way you can look at the t value and find the significance. Here, 0.35. The 0.35 is about this place, about, for example, here. Some place like this. If I have, if I can add something around here. Is it shape? Let's go with this. Okay. It's about here, this place, right? Pointer is here. It's placed down. Any number more than this, if you've got 1.97, should be here. For example, if I compute that, I get 1.98. It's going to be placed like this. Or if I get minus 1.98, it's going to be here, right? It's going to be here, and it is significant. So any number between minus 1.96 and 1.96 is significant. To compute that, there's the other way to look at the p-value. For the p-value, so because we don't memorize this, we cannot memorize. So what's the alpha for the, what is the t-value for the alpha 5% is 1.96. So by default, they created a p-value to look at this. The p-value is the probability of the t-value, right? So and if the p-value is less than 0.05 as an alpha, we can say, if the p-value is more than 0.05, we can say there is no significant difference. If the p-value is less than 0.05 at a 5% error, we can say there is a significant difference. So whenever we compute this p-value based on the t-value, I get this 0.71 or 0.72. So the 0.72 is higher than 0.05. I can say there is no significant differences between hospital beds in 2011 and 2012. So let me go with one other example. Any questions so far, class? No questions? Okay. For the other parts, let me give you one more example. Okay, I want to compute the number of paid employees. So the paid employees is a column V, right? The column V, you can use the same formula here, countifs, but you should change this. For example, if I copy this and you assume that this is a number. Let me hide everything. I'll go with you with just one example. Let me hide this. Let me hide this. I'm gonna compute this manually here, and you assume I'm here. So I'm gonna copy this formula, all of them from here. If you copy Excel, it's happening for one of the students. If you are copy the formula, by default, Excel move everything. So you should change that, right? So this is the number I like to see. This is for hospital beds. You can see it's still the same, but it's changed because the number changed. So look at this. 183047. It was 3031. You can copy this. You can copy the formula from here. But here, this is the column B, right? I should change still column C is the same column. And you know, whenever you put a dollar sign in front of this, the dollar sign in front of this will fix the column. The dollar sign in front of the numbers will fix the row number. So I put the column in front of this because I know the 2011 is 2004. Any variable is 11 and 12. But for this, I should compute for the V. So I'm gonna put the V here and V here. So it's this, right? This is for the V. What is the V? And let me look at the V here. Number is different with this. The V is total hospital. So I'm gonna compute the total, what was the name? Number of paid employees. The number of paid employees, not V here. Let me look at this. Number of paid employees. On payer here, this is V. This is V. Why it's not working there? It should not be like this. Let's see. I have this V2. One of them is incorrect. Okay, this is incorrect. This is incorrect. Let me fix that. Don't see that. This is correct. The same year and V2, this one. And let me hide this to see this one, everything here. Okay, this is the V, right? This is employee and payer. Okay, here. I have the N for the mean, so I have everything here. I should change this to the V. I have this one. This is the V. And I can't see the result because some of them is. Anyone know what this what the error does mean here? No question, no response here.
So
Why
that's
this?
because you didn't change it to the V2 and the V18 is wrong.
If I go with the 2, it's correct. That's correct. Also, if you have something like missing here or no numeric number, let me change this. This is 340 40. So let me have this number here. If I have this one, it's happening for the interesting. It should work here. I don't expect this work here because whenever you create this benefit, if there's a missing, you cannot see the 5 here. So this is, you can copy this one. This is for this year, and look at this. 2012 it should be V, and this is the V. $3,014.31, right? And V2 should be V2. And the same for here, V2. Okay. What's happening here? Okay. And you should compute this one, right? I should compute the p-value here. This is the same. This is this, the same mean. I should compute the standard error divided by square root of this variable. And okay, this is the same mean. And this one divided by square root of this one. So, and for the t value, I can copy the formula here. Okay, it's working here. And I can copy this here. This is significant, right? Look at this. This is 150. If you look at this, is much more than 1.96. So if you look at even the t value, you can understand this is and this isn't correct, right? Oh, that's correct. Okay, let's make sure this is correct. I expect 5025. Okay, there's some missing for this one. 150 is much more than this 1.96, and you can compute that for the other variables here. Okay, any questions so far for the Excel? And for the Excel user, whenever the class asks for the plot, you can compute the plot only based on the mean. So for example, you have a mean for these two variables, and you can compute the plot for these two, right? If you like to see the label here, then you should just go with this. You should just go with this variable. Create this. And then you can say this is the one. You can get this one with the label. This is it. And you can have a title for this. This is, you can do the box plot. For the box plot, you should get entire data to get the box plot, but for the p-value, for the mean test, for the bar chart, you don't need to go with that. Okay, this is for the Excel users. Any questions so far? No questions. Okay, let me save this for the next part. And for the RStudio user, anyone here using RStudio? None of you using RStudio class?
No, I think we're all good. I'm using Excel.
All of you using Excel? Okay, I will review that for the some students who are using RStudio. These are the codes for RStudio. For the RStudio, you should install the R programming first and then RStudio second. So there is a file in the class, HMGT400 step-by-step guideline on exercise. In the beginning of the file, I started how to install the R and then how to install the RStudio. Whenever you install the R and RStudio, if you have any question back to me, I will have a live session with you to just walk you through that. There's a slightly different between Windows and a MacBook user, so but almost we can. Whenever you install that, everything is the same. For the RStudio, you should do 3 steps before starting working with it. First thing first, and either for the Excel user, please create a folder for all of your files and be organized. So otherwise you're going to be confused with all of this. And whenever you're using with one exercise, please save that exercise because the final exam is exactly the same as the exercise, but with a different data set. Same variable, the same name variable, the same function. So if you have a good job on the exercise, for sure you could have a good grade. for the final exam. So make them be organized with all of your files. And if you have any question, please, usually I give you feedback if there's a major problem with your exercise. I give you feedback, okay, this is wrong, and please make sure to read those feedback and back to me if you have any question. Otherwise, if you don't fix that, for sure you're going to have the same mistake for the final exam. Okay, first thing first, you should create a a folder in Drive C of your computer and call it UMUC, and copy all the file on the UMUC folder. So here, to download the file, right click on the file, save link as, or some computer give you save file as, and go to the Drive C folder UMUC and saved it as it is HMGT400 Hospital. The format of this file is a comma separated values file, CSV file. So make sure to have the same format, otherwise you are not able to use this. Then go here and download the codes, save link as, and make sure to copy the codes in this CUMUC. The codes here. So now you have the codes and you have the files. If you have a code and you have the file, you don't need to do anything else. You just need to run the codes. For the first time, if you are using RStudio, you should install this package, dplyr package. To install the package, the code is muted. Whenever the code, this is the pound sign, whenever the pound sign is in front of the line, the code is muted. You should unmute this and install this by running the code. It takes a few minutes. I will not run it here. But whenever you are finished, you will receive a message that the package has been installed. So then mute the package when you install for the first time. And you just need to select everything and run the codes. And if you run the code, you see all the result is here. So I can see everything here. I can see these are the means. These are the standard deviation. And these are the result of the batch sample t-test. I can see the p-value here. The p-value here should be very similar to the p-value in Excel. It's slightly different, but the direction is the same. For example, 0.9 is much more than 0.05. So there's significant. There is no significant here. 0.001, and I compute that right now. It was 0.0. It was here. Here is significant. That is 0.7. That is 0.9. So that's almost the same. It's back the way that Excel and RStudio is computing the p-value. And then you have all of the t-test here, and you have another observation, and you have a plot here. So for the plot, you can click on export plot, copy clipboard, and copy plot and paste in your Word document. Sometimes you can, let me go back here. So whenever you run this code, sometimes if you didn't have a good enough space here, you are not able to see all the variables here. See, for example, here I don't give more space this, and I say with one more variable. To see all the observation here, you should give more space to this. And if I run again, see, I see all of the observation, all of the means here. There is other way if you don't like to save and to look at the console, because RStudio has 4 panels. One panel is this one, code panel, data panel, box and plots panel, and this is the console. The other way is just convert everything as a log file. So if I activated the line 8 and run this, I will see all the information on this file. Look at this, see, UMUC, And this is the file I just created, 550. And these are all the information I need for the exercise. If you are using RStudio, it's much easier. Even with one day, you can get all the results and then populate it during the week. Anyhow, if you decide to work with Excel still, that's a good package. You can do that. You should do a lot of work on that. But do it manually. And this is the RStudio. Any question on RStudio? No one has any questions. Okay, let me go through the individual assignment one. For the individual assignment one, you have a topic, right? Let me go to the class. You have a topic, and you should compute, for example, anyone can provide a title for me for the individual assignment one. One example. Jenny, do you want to go with your topic?
Comparing the MRI and the PET CT.
MRI and PET CT. Okay, MRI and PET CT. This is the data set, imaging data. All the data set is here, right? Also, it's in the week 4, but I converted them to the Excel file here and to the CSV file here. If you are working with Jenny, if you are working with Excel, make sure when you download this data, save as Excel file. This is the data. For this data set, so you have comparing the MRI and the PET CT, correct? You have these two variables here. So you don't need to see any other variables. You can hide them. And you are comparing across all the states, correct?
Yes.
And if I want to use this, I'm gonna mute and even hide them here, so it's much easier to see if you arrive right here. So you cannot see, but something is missing here because the data set is a write data. You can use the count function, because for this you should have a table like this, right? You should have a table that variables, mean, standard deviation, variable n, mean, standard deviation, p-value. Variable you have is here is MRI. I'm not writing procedure, you write procedure later for yourself. Let's see it here. So you have an n. The n is count of this variable, right? The count of this. Let me go here and then copy to this. Stay here. The count, and you have n mean standard deviation, right? And you have, because this is the y data, you can see the count function. The number of n. I'm doing something wrong. Count. You can go with the average function, right? Get the means, and you can go with the standard deviation function. This one, the std s to get this. This is for MRI, the same for this one, right? And then populate this table. This is it. This is the mean. This is the standard deviation. And you know, we can use the same formula I used to compute the p-value. And you also need to compare the means, and then for the means, you can compare them here, right? You have MRI here. You have a PET CT. And you have a mean, right? The means is here, 207. And you have the means here. And you can easily create a bar graph. So another title here. This is the value. So let me look at this. There is a file, draft of the file. For the draft of for the individual assignment 1, I don't need you to just go through the literature review. Just one short paragraph as introduction is enough, and then go to the method section. For the method section, start with your hypothesis or your research question based on your topic. Usually, if you have a topic, for example, comparing MRI procedure, comparing number of procedures between MRI and PET-CT in Minnesota, a hypothesis should be, is there any significant differences between variable 1 and variable 2? Is there any significant differences between MRI and CT procedures in Minnesota in 2012? It should be hypothesis, and then you should go, Jenny, and describe your data set. For the data set, you should say, I'm using the Minnesota data set. This data set has 497 observation. The observation is based on each hospital, each facility, and then the data published by this center, or because you don't know the center, you can say I'm using the data from the class, and then cite this, and it's going to be data sets. And for the method and material, you should first use the table like this to describe your variable. For example, here you have an MRI, you have a CT, PET-CT, and the definition is a number of procedure. The MRI is a number of procedure, a number of procedure. Description is a numeric variable for both. The source is the Minnesota data in the years 2012, and you should source of the data here, Minnesota Health data in 2012, and you should make sure you have a title for the table. And then we will look at the method. For the method section, you should describe which type of the test you are using, which type of analysis you are performing. You are performing the descriptive analysis for the individual assignment. I never ask anyone to do the regression model, so you have a descriptive analysis, and you are looking at the mean standard deviation, and you are using a t-test to find the mean differences between two variables. And then please make sure to use at least one citation to add one sentence, two sentences to describe the t-test. The way you use that, you are using the Excel package, and then add one or two lines about this, and then that's it. And then go and describe your results. The result first, you should describe the number of observations here. For example, here we say I have 229 and 99 MRIs numbers comparing to 52. On average, MRI has number of MRI is at 2048, and in comparison to number of 657 PET-CT, with a really high standard deviation. That means there's lots of variance between each centers. And then if you're compare them as a figure here and discuss about the figure and say, okay, the figure shows the same thing. And then use the same table. I already used that to populate your observation here. Make sure to add a p-value here. And discuss the p-value. What does it mean? Is there a significant difference between them or if not? Whenever you have this one, you are finished for the result. And for the discussion, basically for the discussion, we don't have more than two, because you have only one topic. You have a one first paragraph. The first paragraph, you're gonna say, I'm doing the association between MRI procedure and a CT procedure. This is, you start with this, and then you say, okay, what you found there is a significant difference between these two. And then you should discuss your findings. Why do you think that there is a significant difference between MRI and PET-CT? Is it because that's cheaper? It's because that's high tech? And what do you think about this? And then you should discuss, provide one or two policy suggestions. For example, if you are in the position of the manager in the health department of Minnesota, what's your suggestion? Do you think it's a good idea? It's not bad idea to have a higher MRI? For that and policy suggestion, you should look at the cost viewpoint of the cost effectiveness. For example, I'm going to say the MRI is higher, expensive, so I prefer to stay with the PET or otherwise. And then that's the reason you are suggesting this. At the very end, you should go with a limitation. You can modify the sentence in the paragraph here, because this is the individual research project. This is the student, or if there is the data set is of 2012, probably after 8 years of data, we expect to see a different picture in the Minnesota. And then I discussed about the policy and the recommendation and discussion. For this study, so put everything together, because I don't expect to see. For the team project is a different, it could have a conclusion and recommendation, but for the individual assignment, 2 paragraph all should be together, and you can conclude your site, your individual assignment with a limitation. And then if you use any reference, please use APA format and write about this. It's maximum should be 6 pages, 4 or 5 pages the best. Make sure to add the title page. I have a student, I had this in the other class, they submitted that, they didn't forget to write the name, they forgot to add the title. They make sure to have a title, your name, number on the class, HMGT400 this one, because I have 6, 80 and 81. So make sure to add a class number here, and the date, the most up-to-date date, and the assignment 1. And this, all of the format is here. You just need to modify this. This is the way I'm looking at this individual assignment 1. Any question for the individual assignment 1 class?
I have a question.
Go ahead.
For the exercises and the assignments, how many decimal points would you like us to use for any of the values?
Very good question, thank you. Usually for the p-value, not less than 3 decimal, maximum 4, not less than 3. And for the mean and standard deviation, 2 decimals.
Okay, thank you.
And if you are working with RStudio rounded all the numbers, this is fine for the exercise. You don't need to. Yeah. Thank you, that was a very good question.
Thank you.
Okay, any other question, class? Okay, if you don't have any question, I don't have any other discussion here. So I'm gonna save this file and copy and paste to the class, post to the class. Okay, and thank you everyone for your participation.
Thank you.
Sure.
Thank you so much.
You're welcome.
Yeah, thank you very much.
You're welcome, and thank you all of you to be here. Have a good day and goodbye. This is the end of live session today, and today is 6/27/2020, HM24. Goodbye.